Hello and welcome back to part 2 of Introduction to R for Data Analysis. In the previous video, we had a look at different data structures in R, but that was an introductory part. Now, we will dive into what actually each of these data structure is about. So, the first data structure was vectors. So, what is a vector? Vector is a collection of elements of the same data type, and the values can be either numerical, character, or logical. Next is how we can create a vector. Firstly, using the C function. So for a numeric vector, we declare a variable named numVec and assign it the vector C with 5 values 1, 2, 3, 4, 5. Then for the character vector, we declare a variable named charvac, and similarly we assigned the values to the vector like apple, banana, and cherry. Lastly, for the logical vector, we have logvec variable and the values assigned to it. When we are printing these, what do you think the output will be? For the numerical vectors, it would output all the values that are stored in it. Similarly, for the character vector, we will have the output as apple, banana, and cherry. For the logical vector, we will have the values that we had inputted into the vector initially. Next, we can use seq function for creating sequences. Here, we are creating a sequence 1 to 10 with a step of 2. So, what do you think the output of this vector will be? The output will be 1, 3, 5, 7, and 9. Now, next is a vector for creating repetitions. So here we will be repeating 5 4 times. So the output will be 5 printed 4 times. Now, how we can access vector elements? So firstly, we can access them in 3 ways: through indexing, through logical indexing, and through negative indexing. So first, let's see how normal indexing works. So in the num vector, we need to print the value at position 2. Here, value 1. What will be at 2? 20. So the output of this will be 20. Then is logical indexing, where we are initializing a condition that the element in the num vector should be greater than 20. So the output of this statement will be 30 and 40. Lastly, negative indexing, what does this -1 does? It removes the first element from the vector. So the output of it will be 20, 30, and 40, as 10 was the first element and it is removed. The next data structure that we will talk about is matrices. Matrices are something that you might be familiar with, but a basic definition of them, that they are a 2D collection of elements of the same data type, and it can be numeric, character, and any other data type. Firstly, how do we create matrices in R? The first method is by using the matrix function. What it does, it creates a matrix of 9 elements with 3 rows and 3 columns. Output of this will be, it creates the matrix something like this. Then, and we can create a matrix using the filling by row method. Here, the output will be like this. Then, how you can access the matrix elements? Firstly, by element selection, and the second method is by giving their row or column number. So, by element selection, what this line of code does, it accesses the element in row 1 and column 2. Row 1 and column 2. If we take this matrix as an example, these are our rows and these are the columns. So we have row 1 and column 2. Output will be 4. When we are not giving the value of the column or the row, it simply selects the entire row and the entire column. For this statement, the output will be 1, 4, and 7. And for this, because we are selecting the second column, the output will be 4, 5, and 6. The next data type to work with is list elements. So list is a collection of elements of different types. And how we can create a list? Simply using the list function and adding the values to it. So when we are printing this mylist, the output of this will be like this. And this one is for name. For age, it will work in the similar manner. And similarly, for the scores part, the output will be like this. Now, how can you access the list elements? By using the names directly and by using their indexes. So the first statement is calling the name from the list. So the output here will be John. And the second statement is calling the scores. So the output will be scores. Because here we are not specifying what exactly we need. So the entire row is being printed. Then by using indexes, it says in my list, what is at index 2? So in my list, we have 3 main entities that are name, age, and scores. So what is at number 2? Age. So the output here will be age, and what the value age store is 25. Then moving on to the next data structure in R, that is data frames. So a data frame is a table where each column can contain data of different types, and this makes it ideal for data analysis. How do we create a data frame? By using data.frame function and adding the values to it like this. We can add multiple values by using the C function and creating vectors. And finally, printing the data frame. The output of this will be a matrix kind of thing, like name, age, and score as the columns, and their values as the rows. Row number 1, 2, and 3. There will be 3 rows. How can we access the elements now in a data frame? By using the dollar symbol, we can access like df $8. What it will do, that all the entities stored in the column age will be outputted like this. And using rows and column indexing, now the first statement, what does it do? As we understood previously, that row number 1, column number 2, our output will be 24, something like this. And then in the next one, no row is specified, so all the values from column 3 will be the output, that is 89, 95, and 88. The last data structure that you should know in R for data analysis is factors. So what are factors? Factors are used to handle categorical data. And how we can create factors is just simply using a factor function and creating a vector inside it. Like this has values male, female, female, male, and we print gender. That is our factor. So what do you think the output of this statement will be? Well, factors use levels to describe what actually the categorical data has to say, and here in this case, it will output levels as female and male, because these are the only 2 entities that are present in this categorical data. So you can use factors to access levels and changing them. So when you are accessing the levels, so what the output of this statement will be is female and male only. These are the only 2 levels present in our data. And if you add anything, like if you use data for pass, fail, held, so these 3 will be the levels in this data set. Next, for changing the levels, if you want to shorten them, like you can use F and M to shorten the male-female levels. So the output will be M, F, F, M. All the levels are now changed to females to F and males to M. See you in the next video. Till then, happy learning.